What I did here was I gave you guys a little handout sheet in regards to the identities, the trig identities, the reciprocal properties, and all that kind of fun stuff. We've used these in the past. You've used them before. Some of the examples of being able to do that, I'm going to go through a couple of them today. We're also going to do some of the simplified verify problems. The ones that I've been looking at, they're not as nasty as some of the ones we did last year. Well, I should rephrase that. The ones that we did in honors, I did some really horrible, nasty ones, and I know that regular alpha 2, they kind of kept it at a pretty.
No, they were still pretty bad.
Some were pretty bad, I know, but what happens here is we are going to add in the co-function identities and the odd ones, as well as show you how those things work through. Eventually, we will also talk about half angle, double angle, but that's not till.
Sorry.
Anyway, so you guys have all these in front of you now. One quick little thing I'd throw on here is sometimes they will rewrite Pythagorean identities in terms of the radical. So if you have your Pythagorean identities where it was sine squared plus cosine squared, if you wanted to just set it for sine, sine would be equal to plus minus the square root of 1 minus cosine squared. Same thing if you wanted to write that as cosine. Quick little the identity stuff that they use is how you can rewrite some of these. That's all. And obviously it's plus minus, or you can write it as cosine. Plus or minus the square root of 1 minus the sine squared. Okay. Works the same way with tangent. You want to get tangent by itself or secant by itself. Just a little FYI. The book does it from time to time, but it'll simplify things out like that. I didn't copy that on there. I figured you guys could probably write that out. So, the reason we use these things.
Wait, don't change it.
Oh, it's just.
No, you don't.
Yeah.
No, you said that one. So don't you write this? Sounds good.
Right. I was just reminding you that the book does this sometimes. That's all. That's not on the sheet. I was just trying to show you how you can get sine by itself or cosine by itself from sine squared.
Are you going to use it?
U theta R X doesn't matter.
I don't know that.
They're just doing something like that. We set theta and equal. It's just another way to solve them through. They use the U because eventually we'll start talking about what's called U substitution. We used that I think twice last year.
Yeah, I used it this
Yeah.
year a little bit.
Did we?
Yeah, it's all a little bit.
And then when we finally made sense, like, oh, that's why that works. Okay. So let me show you what we're going to be looking at. There's a few ways of doing this. You've used the trig identities in the past. You've done this, you've simplified, you've worked through it. You've taken something like secant is negative 3 over 2, and you know tangent, and they'll say tangent is greater than 0. That alone tells you what quadrant you're in. Where is secant negative and tangent positive?
This was on the test. No, but it's
Correct.
opposite.
No.
No, it was the second.
Yeah, this would be 3. You guys are all big, deep sigh of relief there for a second there. Okay. So obviously this is going to be quadrant 3. Now, a couple of different ways you can do this. Secant is the inverse of what trig function? Cosine. It's the reciprocal property of cosine. So that means that its cosine is negative 2 over 3. Be okay with that?
I probably did.
Now, if it's placed in the third quadrant, it's placed in the third quadrant like that, and then bless you, that means theta is bounced here for its reference. Vaguely remember that?
Yes.
Right. Negative 2 in relationship to the theta has to be the adjacent. 3 then would be the hypotenuse. And then you can solve for the opposite using the Pythagorean theorem. You guys have all done that before. Another way you can do this is knowing that you have cosine, you could figure out sine by using this. another way of doing it. It's another way of doing that. Now, if I want to get sine by itself, do you agree with that?
Sure.
This is pretty straightforward. So let's substitute in. I know that cosine of u is negative 2/3, so then it would be 1 minus the quantity, negative 2/3 squared. So far, so good? And that's going to equal it's kind of a long way of doing it, but it works the same. Honestly, I would just use Pythagorean theorem. Works the same. Did you know sine squared plus cosine squared is Pythagorean theorem?
Yeah.
Sine, cosine, unit circle, 1. What? Pythagorean theorem. Anyway, so you get 1 minus 4/9. What's 1 minus 4/9? 5/9. And then how do you undo squaring? Square root. What's the square root of 5/9?
Root 5
So look at that.
a long way to do it.
There's a long way to do that because if you started off and just went from here, you know that had to be root 5. Okay. It works the same. It works exactly the same way. Okay. Just another way of showing you that you can use a trig identity to solve this. Because this trig identity is the Pythagorean theorem. Because, yeah, yay, look at that math. We mathed something cool. To be honest with you, I'm just going to do it this way. It's quicker. Not too bad. And could you write out the 6 trig functions off of that? You've been doing that for a while.
Is this homework accurate or?
What's that then? Slow it down? Sorry.
Okay.
Yeah, remember all I did here was just look at the square root of both sides. And then we know that it's sine is the opposite of our hypotenuse. We already had the hypotenuse before we just said about that. Yes, ma'am. Hiding the coffee.
Is this accurate or not?
Pretty close. I looked at it for what we're doing today, it'll be fine. Okay. So let's take a look at the next setup then. Actually using the simplify, verify stuff. How to simplify and verify. Can I go with one? Yes, sir. I want to simplify this. I want to simplify this. See what I can do to simplify it. So I have sine, cosine squared minus sine. What do those two terms have in common? Sine. So I'm going to factor out a sine. Cosine squared minus 1 is pretty close, and it's pretty close to Pythagorean identity, isn't it? Pythagorean identity says sine squared plus cosine squared is 1.
But
So-
cosine squared minus 1.
It would have to be sine squared would equal 1 minus cosine squared.
Yeah.
So what would you be able to do to turn this around? What can I factor out of that to change the signs of it?
A negative.
Negative, yeah. If I take out a negative of that, take out a negative 1, I get negative cosine squared plus 1. And then I can rewrite it. We okay with that? So we get negative sine of x, 1 minus cosine squared. These are the big giant puzzle problems. And what's 1 minus cosine squared? Sine squared. What's sine times sine squared? There you go. And you're done. Yep. Try to get it simplified out as far as you can go. Gotta tell these bozos about halfway. Oh, sorry, Trent. You're about halfway in time, just so you know. Hey, Chandler, you're about halfway in time, buddy. No.
Oh.
Do you remember what it meant to verify?
No.
Yeah.
What did that mean?
They have the equal sign.
Correct.
Oh God, I remember that worksheet.
Make the stuff on the left look like the stuff on the right. Sir? I got it. Make the stuff on the left look like the stuff on the right. Here you go, sir. Yeah, there's not much to this. And it's
Are
lots.
we in a quiz on Friday already?
Oh, that's what we're planning on.
Oh, no.
Okay.
That's crazy.
So if I want to make the stuff on the left look like the stuff on the right, what's the first thing you try to look for? Common factors. What do they have in common?
Cosine.
Cosine. So if I factor out a cosine, I get cosine squared plus sine squared. Okay, I'm notorious for when we're writing out trig identities to leave off x or theta or u or anything like that. Are you guys going to be offended if I forget to put an x in?
Can we do that?
I'm highly offended.
So there's
Yeah.
I'm asking for your forgiveness that I forget this a lot.
Can we do that?
Is that better?
Yeah.
You feel whole again?
No, that's not.
No,
I don't
actually.
Let's go.
So you'll accept it if we forget the thing?
It's usually not. To be honest with you, it's not that big.
It just
It's not
makes it
that
messier.
big. That's really all it is.
Just slide it under the door.
I was about to,
Shoot
but
it.
I don't think it's calculated if it's underneath the door. Thanks, sir. So what's cosine squared plus sine squared? One.
One.
Oh. Cosine is cosine.
Cosine equals cosine.
How nice. But none of these look like this on our quiz.
I don't know. Haven't written it yet.
Oh,
Yeah.
Because that equals.
Okay. Let's try another one.
Are we gonna?
1 minus 2 cosecant theta
Oh, my gosh.
all over cotangent. I want this to equal tangent minus 2 secant. Okay? Now I have to think back about all the different reciprocal properties and things like that. One of the tricks that you may or may not have remembered from last year is that when you only have one value in the denominator and 2 in the numerator, split it apart. Make multiple fractions. Make multiple fractions. Because then you get 1 over cotangent minus 2 cosecant cotangent. What's 1 over cotangent? Tangent. Okay. Now, cosecant and cotangent are both inverse, or sorry, reciprocal properties.
Yep.
Are you okay with that? So what I'm going to do is rewrite them real quick. If cosecant's in the numerator, when I rewrite that, what does it become? Well, yeah, we'll bring the 2, so it'll be minus 2. So this becomes 1 over sine. Oops. And then up top is going to be times the tangent. Because it was cosecant over cotangent, so it was cosecant times 1 over tangent, or excuse me, 1 over cotangent. So I flip them around. What is tangent in terms of sines and cosines? Sine over cosine. So now we're at tangent. Exactly. Notice the sines would drop out. Sine over sine. So you get 1 over cosine.
What is tangent?
And we did it. There's a lot of little subtle tricks that are thrown in here. Okay? There's a lot of little subtle tricks that are thrown in about simplifying these out. It usually tends to go with bouncing back to the older stuff, some of the reciprocal properties, the standard set, the sines, cosines, and tangents, rewriting them in terms of sines and cosines and going from there. That's usually your best bet for a lot of these. Anytime you see something that's squared, try and see if you can figure it out in terms of one of the Pythagorean identities. That's how those things work through. I don't know if the stuff you have for tonight is going to have any of those newer function identities. I don't believe so. I don't. No. Oh, I know. Let's look at this one. Are we okay? Can I go to a clean one real quick?
Yes, you can. Oh no, why is there a
I want to simplify this. I want to simplify this. Yeah, it did.
Dang, just really
Now, cotangent of pi over 2 minus x, that's one of your new identities. On your sheet, that's there. What does that equal on your sheet? Tangent. It's on your sheet. It's one of the newer identities. Whenever you have a pi over 2 minus x for the 6 trig functions, those are called the cofunction, what's that name?
Yeah.
Cofunction, I'm always sure they cofunction or cofunctional. That's how those things work. Now, the reason, if you think about it, sine of pi over 2 minus x, remember how I showed you guys when we graphed sine and cosine, that they're just pi over 2 moved from one another?
Yeah.
That's kind of why this works.
So then, like, is that it, or do you have to do more?
What's tangent?
Oh, sorry.
So you get sine over cosine,
And then cosine.
and what happens?
It's just cosine to cosine, so it's just
The answer is sine. Sorry, I didn't put my theta in. Don't hate me. Oh, sorry, it should be x. Now you can really hate me. giant puzzle. Yay.
We're gonna get the machine.
No, we won't.
It's impossible.
Seriously.
I believe, you guys, did I give you guys all that, that laminated sheet beginning of the year?
Nope.
Yeah.
Yeah.
I think we're gonna start falling back on allowing you guys to use that now.
We got 'em.
Because that's on, this stuff's on there.
The yellow sheet and the purple.
I believe it's on there. It should be on
Oh,
there.
it's right
It's in my
here.
binder.
Can I see that real quick? Nicole?
Oh, that.
Yeah, no problem.
Purple,
Oh,
that's
this
it,
paper's
purple.
stuck to it.
It's also yellow.
Yeah, I see.
A little bit of white.
Spontana and I were talking, I think we're gonna be okay going back to these.
It's like, that's chemistry all over the
I mean, it's not just gonna happen.
place. You wanna what? Because I already did my time. I say again, your noodle on the
Wait, it was like, when was it?
K-minus.
Oh, no, it's not.
I'll let go of most of this. I'll ask him about that. Sorry.
Oh, but it's okay.
Nah, you call this shot. Nah, he's done this longer than I have. Hey, let's see if you can do this. Let's factor trig.
Oh, no. Stop writing on my August kind
Let's factor trig. Secant squared theta minus 1. Let's factor it. Hey, this is kind of like U substitution.
In a way.
You guys ever remember seeing U substitution before? Do you know what that means?
Not
We used
before
it a
you.
little bit.
You used my
early.
face.
Yeah, I never understood.
Yeah.
When we did identities before.
Yeah. What happens with what's called U substitution? U substitution is a great math trick. It allows you to take something that looks like crap and make it easier to work with. A little less crappy, exactly. So what we do here is I'm going to show you this way. I'm going to let secant of theta equal u. You don't have to do it this way, but I'm going to show you how it works because it's real clean.
Have to be you or not.
You can use x, you can use whatever we used Caleb's face. We did. We used his face last year, I think, for this. So now if I use that, I get u squared minus 1. Is that a perfect square?
Yes.
Is that a perfect square?
Yes.
Is that a subtraction symbol?
Yes.
So what does it factor out to be? It's like x squared minus 1. X plus 1, x minus 1. And then what was u in the first place? Secant. You just put it back in. You know, like I said, you don't need to use that. And there's your factor form. Yes, sir? Should. Should.
I thought
If we don't want to.
have to.
Should. I'm going to start forcing myself to, so yes.
Gosh darn it.
And now, it works better when you have, the next example, that 4 tangent squared theta plus tangent theta minus 3. It's a little bit easier to see what you're factoring when you don't have tangents. There's too much. It just looks ugly.
I'm gonna do that.
Yeah. I'm just going to put it on a clean sheet real quick. What am I going to let u equal this time? Tangent.
Choking.
Tangent squared or just plain?
Just plain tangent. And then I factor it. What times what's negative 12? You add together to get positive 1. 3, 4. Remember factoring by grouping?
Yep.
Do I have the same thing written down in both parentheses? Yep. So what I'm going to do, just write tangent in right away as I write it out. So I'm going to have 4 tangent theta minus 3 and 4 tangent theta plus 1. Oh, sorry, not 4 tangent theta. Excuse me, just tangent theta plus 1. And like I said, as you go through this, you don't have to show it with that. Hey, all right. Okay. You don't have to write it out. If you want to write it out with the tangents, go for it. Not a big deal, just cleaner. Yes, ma'am. Here? Okay, I did, what times what's -12? You add together to get +1. I did that whole factoring thing. Multiply your tails to the middle term. The T chart.
You better warm up. You see.
That one. Anybody wants to come again? Okay. So I know you've seen this before. Just like I said, do you have to write it out with the U substitution? No. You want to write it out with tangents? Go for it. It's not a big deal. It's just sometimes it's a little bit cleaner if you wrote it out with the U stuff because it just looks easier to work with. Okay? Question on that at all? Hopefully this isn't so bad. All right. Let's factor a trig. Let's try it now when you have to factor when your trig functions don't match up. So what I need to do here is figure out which one am I going to rewrite it into. A lot of times when you see this, think about your Pythagorean identities. When you have the squared term, that was you can do sine squared was 1 minus cosine squared. Cosine squared was 1 minus sine squared. What is it? Tangent squared. I forgot. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. So a lot of these you're going to try to rewrite just to change it to the term that is not squared. So I want to try to rewrite cosecant squared in terms of cotangent squared. What is cosecant squared equal to? So this is the same thing as saying 1 plus cotangent squared. And then what do I do with the 1 and the -3? Yeah, you just combine them out. And now I can factor that without too much of a hassle. I'm not going to use the U substitution here because there's not much going on. I think we could probably do it. What times what is -2? You add together to get -1. -2 and 1. So your two terms to factor out then would be cotangent x minus 2, cotangent x plus 1. A lot of it stems from just going back into the identities. Okay, a lot of it stems back and forth from identities. You didn't get the Lego time helper for Christmas?
But I was looking at a clock yesterday,
Ooh, I'll try
and it
s-
said like 5:18, and I said that it was like 3 something, because I looked at the like.
Try and simplify this. See what you can do. Simplify this. See what you can do. Sine plus cotangent cosine. Take a minute. See if you can figure that out. How do you add fractions?
Um,
Common denominator.
oh man.
What's going to be the common denominator between a 1 and a sign?
Sine.
Sine. So,
So you get sine squared.
fraction on the left needs to be multiplied by sine. So you get sine squared.
Plus cosine.
This one didn't need anything. And what's sine squared plus cosine squared?
1.
1
And then 1 over.
is, very good. That's the trick. A lot of times you guys will forget about adding. When you're adding or subtracting these things, you gotta have the common denominator. That's fine. And it's been a while. I mean, you probably forgot about the whole, oh, I can multiply. Bless you. Go through some of that. It'll come back, I hope. All right. Then, I think we got enough here for first day without a problem. There's enough here for first day. Actually got enough to probably go to, actually probably get in second day as well. So let's see here.
25, there's 5 of those, and then you got 5, 27s.
Yeah, you should be fine. You guys should be able to fly right through these. It looks like there's just one problem that has the co-function identity in it. No, sorry, 2 of them. You should be okay. Factoring stuff is more tomorrow. I think I got ahead of myself with those. No page numbers on here? I didn't know that.
All right.
Yeah, yeah.
First one going?